Hey everyone, in this session we are going to understand about the trigonometric identities. Again, one of the most important topics that we have because we are going to look at a lot of proofs in this section particularly. Okay, so I would suggest you to have maximum focus and let's start. Okay, so there are three trigonometric identities which are very important. The first one is sine square theta plus cos square theta is equals to 1. Then we have 1 plus tan square theta is equal to sec square theta. And the last one is 1 plus cot square theta is equal to cosec square theta. These are the three major trigonometric identities. The others would be derived from this ones. Okay, so let us start with the proof of the first one. So I'm going to take the first one first and I'm going to prove this for you. So we are going to prove that sine square theta plus cos square theta is equal to 1. By now, I assume that you have seen my previous videos where I have given you the values of sine theta as 0. So at 0 degree, if I would take theta is equal to 0 degrees. So sine 0 degrees is equals to just 0 and cos at 0 is 1. So if you will plug in over here sine 0, so sine square 0 degree plus cos square 0 degree is equals to sine square 0 degree will be 0 plus cos square 0 degree will be 1. So this comes out to be 1. Proved. Again, at theta is equal to 90 if we take. Okay, so sine square 90 degrees plus cos square 90 degrees is equals to 1 plus 0. That's going to again be 1. That means it holds true for this one as well, right? Now let's say I am taking theta, which is in between 0 and 90. Okay, let's see now how does it go. So I'll make a triangle for you people. Okay, just look at it. So I'll say let's take this one as theta and A, B and C. So sine theta for this one will be AB upon AC, opposite over hypotenuse. Cos theta will be BC upon AC, adjacent upon hypotenuse. So let's see. You should also know that this is a right angle triangle. I already mentioned in the beginning only that we are chasing only the right angle triangle trigonometry as of now. So for this one, we should also know that AB square plus BC square is equals to AC square by Pythagoras theorem. Fair enough. So now let's put these values into the equation. So sine square theta is going to be AB square upon AC square. Cos square theta is going to be BC square upon AC square. Okay, and if I'm going to add them up, so sine square theta plus cos square theta is equals to, check, AB square upon AC square plus BC square upon AC square. AB square upon, what do we have? AC square plus BC square upon AC square, which can also be written as, since the denominators are same, we can add the numerators, AB square plus BC square upon AC square. And by Pythagoras theorem, we know that this is the opposite or perpendicular. This is the base. When they are squared and added up, we get the AC square. You can also see over here, AB square plus BC square is equal to AC square. So AB square plus BC square is equal to AC square, and they cancel out and result in 1. Hence, by any means, cos squared theta plus sine squared theta is equal to 1. You have the further versions of this identity. That could be that sine squared theta is equal to 1 minus cos squared theta, and then you have cos squared theta is equal to 1 minus sine squared theta. Anything is possible, guys. These are just the versions of the same identity. Okay, next we will move on to the next identity. That was 1 plus tan squared theta is equal to sec square theta. I'll draw another triangle for you. So A, B and C. Now let's say this is theta. This is a right angle triangle. You should know that AB square plus BC square is equal to AC square. Now we will plug into this equation. So 1 plus tan square theta. To find out the tan theta will be AB upon BC, and sec theta is equals to, sec theta is the flip of cos. What is cos? Cos is BC upon AC. So sec theta will be AC upon BC. Okay, so let's just do it. 1 plus tan square theta may we will put AB square upon BC square. Let's solve it further. It's going to be BC square plus AB square upon BC square when you will take the LCM. Now BC square plus AB square. So BC square plus AB square is equal to what? AC square. AC square upon BC square. What is that? When you will square the sec theta, so sec square theta is going to be AC square upon BC square. So AC square upon BC square is sec square theta, which is evident from the fact that this is also sec square theta. That's it. We have proved that 1 plus tan square theta is equal to sec square theta. Further versions could be sec square theta minus tan square theta is equal to 1, or 1 minus sec square theta is equal to minus tan square theta. So these are the versions, but I think this is a less used version. Rather than, I would just write it this way, that tan squared theta is equal to sec squared theta minus 1. So these are some versions of the same identity. Last one, 1 plus to cosec squared theta. Again make a triangle, and now you freeze the video and try this all by yourself. Theta, A, B and C. So we will first find out the cot theta. Cot theta is 1 upon tan theta, which is so base upon opposite. So BC upon AB. So when you will square this up, we will write it down as cot theta square is equal to BC square upon AB square. Similarly, cosec theta is going to be 1 upon sine theta, that is going to be AC upon AB. So cosec square theta is going to be how much? AC square upon AB square. Okay, fine. So 1 plus cot square theta is BC square upon AB square. We will further solve it. So it's going to come out as AB square plus BC square upon AB square. Now AB square plus BC square. You should know the fact over here that this is also a right angle triangle, and with the Pythagoras theorem we can say AB square plus BC square is equal to AC square, right? It is by the Pythagoras theorem. Hence, with this fact, we can say that AB square plus BC square is going to be AC square upon AB square, which is already here. Alright guys, now you can see that this is what exactly? Cosec square theta. So we got cosec square theta, and this is how we prove that 1 plus cot square theta is equal to cosec square theta. Further versions could just be, so cosec square theta minus cot square theta is equal to 1, or it could just be that we will figure out as cosec square theta minus 1 is equal to cot square theta. These are the other two versions that you can use, but all have been derived from the same three identities only. So when you know the three identities, you pretty much know a lot of trigonometry, by which you can do the executions and applications in further areas to find out. The next video is based on the applications of these identities, so must watch that as well.